Okay, this diagram shows a magnet. Around the magnet is a magnetic field. You can't see this or you can't touch this, but we know it's there because if you put any magnetic materials or any other magnets in there, then they'll experience a force. So for example, around this magnet, if I bring a north pole towards the south pole, then it will attract. We can say that opposite poles attract. Okay, so if I bring a south next to a south, then actually it will repel then. So we can say the same poles or like poles repel. If I bring a north and north together, they will also repel. If I bring the magnet next to some steel paper clips like this, it will attract the paper clips. Okay, that's because the steel is a magnetic material and it gets magnetized. So one end of the paperclip like this becomes the north and the other end becomes the south. Now if I had brought the north pole towards the paperclip like this, then actually the top part would become a south and the bottom part would become a north. So it gets magnetized in a way that it always attracts. And also if the magnet is strong enough, we can pick up another paperclip or more even, and those would also get magnetized in a way that always attracts. Okay, we've got a bunch of materials over here, and I'm going to separate them into three groups. First of all, non-magnetic materials, which will not experience any force when you put them into a magnetic field. Then we've got magnetic materials, also known as induced magnets, which will always be attracted. Okay, then we've got permanent magnets, which have a north and a south pole, and they will attract if they're opposite poles, and they'll repel if they're the same poles. Let's start with the easy stuff. So all these materials over here, ceramic, wood, stone, glass, plastics, they're non-metals and they don't feel any force when you put them near a magnet. But there's also quite a lot of metals that go into this group. For example, gold, copper, aluminium, also silver. Now, people might be surprised by this. That's because a lot of metals that we come across nowadays, we might have a bit of iron in them, which makes them magnetic. But most metals are actually non-magnetic and they don't experience any force. Okay, then we've got the magnetic materials, and we know iron and steel, we've already done that one. That's a very common magnetic material which always attract when you bring it next to a magnet, but also nickel and cobalt. Okay, so these are the elements that you can join them with other elements as well and make alloys which are also magnetic. And then finally, permanent magnets, of course, we've got bar magnets and you've got these U-shaped magnets which can attract or repel depending on what other pole you bring next to it. Okay, in this example question, we've got an unknown object inside a bag. In diagram 1, when you bring a north pole next to the bag like this, it is attracting the bag. When in diagram 2, you bring a south pole next to the bag, it's also attracting as well. Describe and explain the observation. You may refer to side A and B in your answer. Now, if it's always attracting, hopefully it's obvious that it's a magnetic material inside the bag. And why is it attracting? Well, when you bring the north pole in diagram 1, it's because side B is becoming a south pole and is getting magnetized, it's like so, and is attracting it. While in diagram 2, side B is actually becoming a north pole and is being magnetized like that, so that it always attracts.